Zoom arrow pointing to YouTube.
Okay, it's live stream that I got.
Okay, Ron, you're on.
We don't get a little flag. Gentlemen, on the screen, you see pictured members, stalwart group members of the board and supporters of the Central South Coast Longtime Astronomy and Telescope Club. It's called the Santa Barbara Astronomical Unit, going on 70 years, I do believe, and this is the SBAU Astro Hour, our weekly online blog using Zoom, a little late today, being the 15th. Well, it's tax day. We were all doing our taxes, watching the Trump trial. We're going to focus on the latest space news and discoveries, cutting-edge cosmology, some hardcore astrophysics. And I got to tell you, folks, featuring some of the brightest and most knowledgeable people in Santa Barbara that I know. They're just not really up on Zoom that much, but that's all right. I'm sorry. The SBAU Astro Hour. I'm your VP and host, and getting my voice back. We'll meet the rest of the club's movers and shakers in a moment. Meanwhile, you can watch us, hopefully, comment or questions using YouTube and all the past programs, 163 of them. This will be number 164, delayed 1 week because we were all out at Camino Real Marketplace last Monday, the 8th, for the partial eclipse of the sun in our area. So welcome aboard, April 15th through the 21st, 2024. And let me tell you what we're going to talk about today. Last of the winter sky. Look up at the Orion area and the stars and the big nebula. Springtime birds are reappearing in the night sky, everybody. Achille the eagle, the duck cluster. We're going to find out why Jerry referred in his talking points to the dumbbell as Chuck's Nebula.
That's me.
And the first quarter moon in Cancer, not far from the Beehive cluster, carbon stars. What are those? We're going to get into it. I'll tell you, asteroids are going to be on the agenda and also on the menu. Solar prominences today. Got a brand new board member, not board member, but a club member, David Grossman, who's got an article called Music of the Cosmos in a recent astronomy magazine. He was there at Friday nights, moved up, 1 week? I guess we switched Star Party weekend with our regular meeting, and we welcome him aboard. I don't know if he's on board since we had trouble signing on. Let me really quickly tell you a couple of headlines. Well, let me introduce the guys first, and then I'm just going to read you a couple of quick headlines I read recently about astronomy in the New York Times. Ladies and gentlemen, on my right, on the screen, Jerry Wilson, beloved president. You might want to turn a lamp on. Your face is darker than the rest of us. That's all right. We don't need to see it. His wife, Pat, was there at the meeting, and she's such a supporter. And thank you very much. We have Chuck McPartland at the bottom of the screen, incredible outreach coordinator. He's married to our incredible merchandise.
What's the name of the cat, Ron?
Shadow.
What is it?
Shadow.
Okay, well, just to show you how much this man puts into it, he's allergic to cats, and there it is right now.
That's why my eyes are red.
I had to get rid of an Angora long hair because of the dander. I learned all kinds of stuff. And Pat's okay. She's there with him, merchandise manager and our new treasurer for the new year. Tom Totten got us on the air. He's to my left. He's back in the Midwest.
I think I was blocking you guys from coming on the air. I think I was still logged into the account. I think that's what. So I just came back from lunch here in Kalamazoo, Michigan.
Man, I tell you,
had a Reuben sandwich haven't had one of those in a long time. It's wonderful.
And speaking of Reuben, he sent me an email that he has someone who wants to donate a scope, so I sicked him on you.
Okay, I'll look for that.
Gutierrez, is that his last name?
Yes.
Yeah.
I haven't seen him in years. He went the same way as Art Harris, and
well, his wife is Alva is immune compromised, so he's real careful about going out and mixing with people.
Okay, and I often wonder what happened to Martin and Janet. I see him occasionally, but what's his name? Ocampo.
Edgar.
What's his name?
Edgar.
Edgar. He's back. And on the screen, I'll do the on-the-screen guy. Tim Crawford, who's married to Karen, is joining us. And Bruce, I think, are you there? Can we hear you, Bruce?
I don't think so. I think he's just got it.
Yeah.
All right, we're on the air anyway. We're live.
Tom Totten, the YouTube live is working.
Are we on?
Who locked out there? Is Ron, everybody else hearing me?
Yes,
I hear you fine, but are we being seen by the members?
Yes,
Yeah.
yes,
Okay,
we're
that's what
live.
Tim just said.
And Bruce Murdoch runs the local theater organ society. He's a definite member of the club that's always there and supporting us. Let me give the wives' names. Bruce is married to Bonnie, and I guess everybody knows who everybody is these days. You're married to Suzanne. Is she back there?
Yep, she's painting right now.
All right. Well, welcome aboard. You're going to stay the whole hour with us? I guess you have to, don't you?
Oh yeah, we'll be fine.
These may be future. Let me throw this in there very quick. Friday, the 5th of April, New York Times wrote this. Scientists have discovered a major flaw in their understanding of dark energy. That could be good news for the fate of the universe. I believe we touched on something like this recently.
We did, and what we touched on was more scientific fact, and now it's working its way through the popular press. And of course, it's becoming more sensational and more important as it gets going.
Almost like those distant shots of galaxies by the Webb where we went.
Yeah,
Last
but it's a
Wednesday.
hypothesis.
Okay, well, we're a very popular science. That's why we do well in our meetings. Peter Higgs died. He predicted the existence of a new basic particle, as you all know, sparking a 12, try that half century, half century search. And they found it, and now I guess a Nobel Prize was awarded to the guys that found it or to him. He just died at 94 about a week ago. Peter Higgs, Higgs boson particle. Okay, what we do every week, and a little later today, I guess we sign on about 11:20, and we'll go off about the same time, is check the silly forwarded science cartoons, silly science stuff. Like this is one view of the eclipse as it gets covered over by the full moon. It goes, oh my God, I can't believe I just got mooned. We're going to have more on the eclipse.
See that one.
All right, you set out 18. I'm not sure if we'll get all 18. This is a couple of
No, I just picked out 6.
I understand that. So we're covered for the next 2 weeks.
Right.
These are a couple of stick figure bubbleheads. Apparently found the treasure. Let me look at. Let me see if I can get it from under the root, which is the key word. It's $10,000 treasure chest, but when you get it out from under the root, the square root, it becomes $100. That's sort of appropriate.
I don't get it.
How did you?
You're too square.
Joke. Okay, here's more eclipse photos. We've got a couple of eclipse.
This summarizes all the photos you'll see.
Well, why don't you go through all 8, Mr. President, starting at the top
Well,
left.
there's the standard picture of the sun
Okay.
with the moon in front. And there's what we saw here in Santa Barbara, the partial eclipse.
Not even
There'll be the reaction shot. You turn around and take a picture of everybody looking at it. then there's the super fancy lens that shows all the magnetic field lines and prominences, which we did see here on the partial. Normally you only see that with your naked eye on the actual eclipse, the total, but we have hydrogen alpha camera telescopes that show the prominences every day. Then there's the person that has focus issues, because automatic focusing doesn't like to work on these kinds of things with a big dark background and something that's small in the middle.
I had a bunch of that.
Yeah.
Okay.
Then there's the traffic jam.
Right.
And then there's the view from space, which shows the astronaut's view of the shadow moving across the Earth. And then there's what one of our club members ran into was frustratingly looking up at the clouds. So
they showed this same series Thursday nights. It's Astronomy on Tap downtown at that bar that Sandy and LCO runs. They ran this funny stuff. Okay, hit us again. This one took some time to figure out. It's what did you call this? Unappreciated pun.
Yeah.
Bruce didn't get it. Bruce is not with us still, is he? I hope he's on board.
Okay.
I hear something in the background. I'm wondering if that's him.
But this is fairly simple. I finally got it. The letter E and there's paper clips becomes an E clip.
It's an eclipse.
That's it. Okay, got it. All right, this is one of my
This
favorites.
this is the periodic table in words.
Ah,
All right, regular metals are laying in the middle, up on the upper left, slightly fancy protons. You want to
Mhm.
go anywhere, the gentleman, and pick one out?
Down here is the noble metals, osmium, platinum, gold, silver, copper. These are the weird metals. And these ones are toxic. They're the murder weapons.
Oh my God, really?
We are here. This is up at carbon where we are.
Okay.
This is boron. It's fool's carbon. This is just regular dirt, weird dirt, slightly fancy protons, which means hydrogen. Ends in a number, so let it slumber. Don't bother learning their names. They're not staying long. These
ones that are
very
high
short
fermium,
half-lives.
Californiums and fermiums.
Yeah, americium.
Yeah. Well, I'd love to know why we give no respect to elements 3 through 7, or is it, no, 5, which is lithium, and boron is in there. It seems to always jump from hydrogen to helium up to carbon, which is
This
6.
is weird dirt. That you're covering weird dirt up to here. So right across there.
It doesn't go through the stages in between boron and lithium?
No.
Okay. This is
Well-
great. I'm going to save this one.
I don't get the lawful neutral.
The what?
The lawful neutral.
Those
The,
are
the what do you call
Oh,
those
there.
guys? Noble,
those are the
noble
noble gases.
gases.
Oh, no.
Lawful neutral,
Lawful neutral. They are neutral by law.
I guess. Okay. Okay.
Okay, Calvin is on the ground. A problem we all have. He said, my whole problem is my lips move when I think. That's the problem we got to watch for, gentlemen.
I think that does our 6 for today.
Yeah, that's okay. So
I
the
think we've
others-
got to do an all funny show too. That would be.
you do the
No,
math.
for some reason, we just had a glut of these things last week. But normally we don't get this many per week.
Well, do you know
Everybody was in true form.
Or Jerry, are you saying that you went to this Facebook place where they have these and a whole bunch came through, or?
I'm on several things like the lighter side of science and astronomy cartoons and a couple more, and they're very repetitious. So if the new one comes through, I grab it to the best of my memory. I'm sure I've made a few mistakes in that and repeated.
Stage, a bunch of
But all of a sudden, there just had a ton of them.
Yeah. Well, let's get into the serious stuff and hit the night sky full on. I didn't realize there are birds that are surfacing and other things are going away. The last of the winter sky. The Orion is always up there, though, isn't it?
Somebody's got a TV or a radio going in the background.
Not me.
Here.
I came and sat down and didn't get it fixed. There we are.
Okay.
Thank you.
Okay.
Okay.
So this is a little added thing I put in because it came out yesterday. But this is the Europa Clipper. It's a satellite that's going to be launched in October of this year. And in 2028, it's going to arrive and orbit Europa. And it's
a
going to
big,
check
big
remote.
satellite.
What's that?
It's a big satellite.
The
You
moon
mean
around
Jupiter here?
It's going to Jupiter?
Yeah.
The moon of Jupiter, looking for signs of life. It's going to size up, do precision measurements of stuff emitted from Europa and photograph it and measure its magnetic field and gravitational field exactly. Try to characterize the ocean a little better.
I can't remember. Did they say this thing was just going to orbit continuously around Europa, or is it going to do one of those, diving in and out to see
No.
Europa?
It's going to orbit, at least from what I read. There wasn't a lot about it on the article I found. But it's going to be launched in October, so we'll hear more about that.
Europa is one of 3 or 4 of these moons out there that are all ice or mostly ice.
Most of those moons are ice, Ron. Only a couple, like Io or Rocky, to an extent.
Yeah, right. Enceladus is
That's Saturn's moon.
That's Saturn's moon. Okay. Well, Europa sure had a big part of 2001 Space Odyssey.
Yeah,
Photogenic.
we're going to go see what's going on there.
Our Friday
Hey,
speaker covered that.
This is a full sky view of the night sky for April. probably late in the evening, around 10 o'clock or so. West is over here. Things are moving from east to west, setting. And what we see is the is this right?
This reminds me of the 2 planetarium shows I've gone to, one at the University of Findlay in Ohio, and then yesterday or day before at the Kalamazoo Museum as well, bigger, nice 50-foot diameter planetarium.
Can any of you enlarge that?
You'll notice that Lepus, that is one of the things we're focusing on, is already set.
Right. I kind of knew that was going to happen.
Huh. Okay. So what's going to be missing and what do we welcome back?
This is the late spring, early summer sky.
Okay.
Yes, this is April and May. Well, it depends on the time. As you get into May and June, this is later and later in the evening, or excuse me, earlier in the evening. So this is right now, this is Leo right here, which is, we're looking out of the galaxy, looking out the North Pole. So we have a lot of galaxies up in here. Some very famous ones up here, M51, M101. I can't quite read the numbers there. There's the Leo triplet. There's a lot of things in Leo.
Virgo, downtown Virgo.
Yeah, Virgo cluster. So we're coming in on, this is the part of the sky at the time when my experience shows that we have the most marine layer. So it's the most frustrating time of year. And now we're getting rain, not just marine layer.
Where's Orion's hourglass?
Oh, that's set.
Oh, that's not on the screen.
It's just barely coming up on the right there, Ron, where it says west.
Got it.
You can see Beetlejuice, and he's got his club hanging up there.
Speaking of Beetlejuice, they're remaking the movie with Michael Keaton.
Oh yeah, I saw that.
Spelled
it's a part 2. So Gemini's up here. This is Canis Minor, one of the big dogs. And the other one is
just
Canis
barely
Major
there
down here. And Sirius is just setting. So this is sort of the theme of the first paragraph in our talking points is goodbye to the winter constellations over here. So they're fading out. And the concentration is on the Canis Major down here, which is the big dog with the brightest star in the sky, Sirius. Up here is, and on the previous chart was already set, but this chart doesn't have a horizon. So this is Lepus the hare, and way over here is Hin's
Crimson Star.
Crimson Star.
That mean it's red? Yeah, of course.
Yep,
it's
red.
A carbon star.
And it's a carbon star, and that's what we're going to talk about a little bit. There's also a lot of, these circles are all open clusters. A lot of these things in Monoceros, the single horn or the unicorn. So, and another one for another time is Luton Star.
Did you just say Lepus the hare?
Yeah, Lepus the hare.
Are you kidding me? They have a rabbit and they call it Leap.
Yeah, right there, Lepus.
It's Orion's favorite thing to hunt, and that's what the dogs are chasing.
Oh,
yes.
Oh, that's how they spell leap.
There is a story up there for ancient myths. So this chart is courtesy of Tim Crawford, who shares his star hopping techniques, which I think is the most fun way to find things in the sky instead of punching it in your go-to computer. But you start out here in Lepus with Ameb.
Arneb.
The R is obscure. And Mu Lepus. Mu is the Greek letter right there for Mu. So you draw a line between the two and you go out about 2/3 to 3/4 out there. And that little circle is Hind's Crimson Star. So these simple things, the field of view of your eyepiece, about 25 power in most amateur scopes, is around 1 degree or 1.5 degrees. And so you can scale it by setting something up. And it'd be nice if you made it up out of right ascension and declination. axes of an equatorial mount. Declination goes this way and right ascension goes this way. And so you can just move one axis over here several degrees, and then the other axis over here is several degrees. And when before setting circles, I used to sit down and figure out with a circle on a star chart how far you move in this direction, how to measure it. You pick a star on one edge of the field of view and you move that direction until that star is on the other edge of the field of view. And then you know you traveled that distance. You learn the sky that way. This is a photograph of Hind's crimson star. And this is not an exaggeration of color. This is not necessarily the way you'll see it visually, but it is a bright red star.
Is it variable?
Yes.
Yes.
Because
usually carbon stars are.
I just have really a hard time star hopping to that and finding it. It must be a real small dot. I found it before, but last week I was looking for it and think I found it, but it was kind of in a real light orange phase.
When it's in the brighter phase, it looks more orangey to your eyes.
Okay. Yeah. It's just
when it's dimmer, it's redder.
It's just a real tough hop for me. I don't know why. It should be easy. According to that chart, it's real easy, but I have trouble.
You sit down and think about it beforehand and look at the star chart and see what's around it, what the field looks like. It's an easy find.
Oh, okay. That's a good idea. Yeah, thanks, Jerry. That'll help me.
So we have red giants and red dwarfs. Are there any middle stars that are red, the size of our sun?
Speaking of which, this is a histogram. You remember we had last time we talked about 2 weeks ago, we talked about who's that Harvard astronomer?
Abbey Loeb?
Had his harem. No, Pickering's harem. Yeah. And the ladies that were working for him in the late 1800s were the ones that spotted this color distribution, and they pinned down that the color of the star, with the exception of carbon stars, shows the temperature of the surface. And so it goes from red being very cool and then up through orange and yellow, and then I'm missing blue for the hottest, and then white is really hot. And she made up that acronym, "Oh, be a fine girl, kiss me," for the spectral classes, and they started forming spectral classifications for the stars. Well, that simple relationship between the axes don't show well on this one. They'll show on another one. But these it's plots, color, basically color versus temperature. And there's other symbols that have the same properties that it doesn't explicitly show that. But these different branches of this is a plot, a Hertzsprung-Russell diagram plot of the globular cluster M5. So this is not a sample of all stars, but the stuff in the globular clusters tends to be older stars. But it has red giants. It has a different, quite a different set of things. It's a lot. I'm struggling because a lot of this is in the caption, and I didn't capture the caption for the picture.
And where those branches occur kind of gives you a hint of the age of the cluster.
Yeah.
But a general question, gentlemen, that doesn't mean the stars just emit that one color, or we'd have infrared stars we can't see. Or
no, every point on this graph is a star at one time when it was looked at. And so it has this mass, it has this brightness taking B minus V. These are different spectral bands, but we'll get to a better description of it in the next one.
Oh, it's mass and brightness. Okay.
Ron, anything emits along a whole spectrum of wavelengths, even you, okay? And what this is sort of charting is the maximum output, what color it has the maximum output at.
Yeah.
Okay.
The integral of the color to your eye or to these ladies' eyes. We have instruments that do it now.
Okay.
That's the B minus V. The B's and V's are various filters that you use, visual and, another one. I don't know what the B means, but it's blue basically.
Mhm.
But would it be fair to say that most stars just are white or yellow like our sun?
No,
No.
our sun is yellow. It's a low temperature star. It's not a hot star. It's not a big star.
So
Most stars are red dwarfs, Ron. So most of them are red.
okay,
Yeah.
so that means if you were on an exoplanet or on a red dwarf like Proxima b, you'd see
Yeah.
that your sun would be red only?
Your sun would be redder than our sun. The
Yeah.
light during day would be dimmer. But if we evolved on that star, we would see it all as white. That's how we would define white. And then when we came to Earth under a yellow star, we would think it's overbearingly hot and it's too bright. We'd wear really thick sunglasses.
Okay, well, I missed the purple ones on the bottom of this figure. What were they? Purple.
We'll get to
Purple.
that.
Oh, we'll get to the purple ones. Okay. Ultraviolet.
Well, these
No.
branches, you see the purple ones down here are, well, the red ones are RGB.
That's the red
Those are
giant
going-
branch.
Right. Those are going to be the ones that are, I believe that's the carbon star.
Ooh,
But we'll see.
we can talk
So
about
this is what happens to something, namely one solar mass star over its lifetime. It starts down here on the main sequence. And the main sequence is this branch going up there.
Actually, no, the main sequence is off that scale down and to the right.
Okay. Yeah, we're just showing the very top end of
Yeah.
it.
Yeah. Where it starts to branch off, giving us something of the age of M5.
Right.
Okay.
So this one shows the evolution of our sun, or a sun just like it, because everything's determined by the mass of the star. It all starts with a lump of hydrogen and some other metals in it. So once it stops its hydrogen burning, then it goes up the red giant branch.
What is it burning then?
It's burning helium.
That
And it
creates
goes-
what?
it's-
Carbon and oxygen?
To what?
Does that create carbon and oxygen?
We'll get to that.
Okay.
So this goes up this is when the star becomes a red giant. It grows, and this is when it will expand out and encompass probably the orbit of the Earth. But some people have claimed that because of the continual solar wind, our sun will lose enough mass that it will not grow this aggressively to reach the Earth's orbit. It'll stop short of it, and the Earth will survive.
And the Earth will actually spiral outward.
Yes, that's right, because of the lower gravity. But then the Earth will be dead because of the heat from this red giant star. It will have boiled away the oceans and stuff.
Jeez.
Then it comes back down here and it starts burning other materials, and it gets more complicated than just one. Then it goes up here on this branch, the asymptotic giant branch, the AGB, which we saw in the other one. This is the post-AGB phase, where it produces a planetary nebula and becomes a white dwarf. Now,
And when it becomes a white dwarf, it actually jumps way down off the lower part of this chart.
Yeah.
Okay, was that after a hypernova or something?
No, no,
I thought that's how you got white dwarfs.
no,
Okay.
no. They come from stars like our sun that just poof off their outer layers.
Yeah.
But well, Chuck, isn't there a nova stage to make the white dwarf?
Not for this star.
Not for one mass.
There's not enough mass to nova. It passes through this instability strip here, and that's when it sloughs off the outer portions of its being.
I think what you're thinking, Tom, it's not enough mass to blow up in a supernova, but white dwarfs that are siphoning masses off of companions go through the nova stage where you get explosions and stuff.
Oh, I
Yeah,
thought
they
it was one
borrow
of the.
mass.
I thought all the stars like our star would kind of do a little nova when
Well,
it became a white dwarf. Yeah.
No.
It
Well,
shrunk down real quick.
The poofing off of the planetary nebula kind of happens. You
But-
know that there's a little
So, yeah,
outburst there.
So we see the planetary nebulas at nighttime, like the Dumbbell and the Ring Nebula. Are they kind of like our sun? And would
Yes,
that kind of
Yes.
would that be
Yeah.
like a glowing event when it collapsed down to white dwarf? Would be a bright glowing event or not?
Well, the white dwarf is really high temperature, so
but small.
But small. So it's not really that bright, but it is hot, and that's what makes the nebula fluoresce.
But this diagram we're looking at right now,
Okay, thanks.
could this be the life story of Betelgeuse, which they do expect to
No.
explode?
Betelgeuse is too massive.
Oh, it's
This
too
is a
massive.
star the size of our sun, Ron. It's one solar mass.
This one. Oh, I see. Oh, gotcha.
Every time all these kinks and curves are every time it gets through burning something, because the star at any given point in his life is an equilibrium between two things: gravity trying to crush it and energy being released from fusion that's trying to blow it out. And they balance. And as long as that balance is there, the star has a stable size. When it runs out of whatever fuel it's burning in the core, then gravity wins for a short time. Then the pushing out stops and the star just collapses. And it happens fairly quickly. And when they get up to stopping to burn some of the higher elements, the lifetimes are very short of the burning. And then it's very abrupt, the collapse. And at the point up where it's going to produce the planetary nebula, the collapse is so hard that it slams down, and then it creates a shock wave that bounces back up, and that's what throws the outer layers off when you get into these hard collapse episodes. And that's in this instability region, and that's what throws the outer layers off. But it's not an explosion. It's just a sudden compression and a reaction to it.
So there's no stars anywhere that just burn out and fizzle away and become ash and are gone. That never happens.
That's what a white dwarf is. It's ash.
Yeah, that's just what happens here.
Oh, okay.
What's the ash made up of?
Carbon and oxygen mainly.
Not the higher guy.
Okay.
Okay.
Now, this is what happens. An exaggerated form of that happens with a 5 solar mass star, where it goes through different features. This is determined by modeling, which has become very accurate since the 1930s, when the first models of these reactions were developed, once they understood what radioactivity and fusion and fission was. So this one is, it goes through these stages through an instability gap, and the post-AGB, this either becomes, for this size star, it will also produce a planetary nebula and a white dwarf. But much bigger stars than this will produce a nova or a supernova.
What is the blue loop?
That's where it gets hot. Again.
From a red giant, it'll get hot again?
Yeah.
Yes.
Huh.
See, this is where it's evolving while it's burning helium. And then it stops, and then it collapses. And then it starts burning other things going through here. And then it gets back to a burning what's called an asymptotic giant branch, an AGB.
Okay.
Is it my understanding, gentlemen, there are 3 kinds of novas, and I'm not sure you can cover them all. There's hypernovas, supernovas, and kilonovas.
And then there's plain old novas, which aren't really
well, other than your sign-offs on emails, you're right. Happy Nova or whatever, but does that involve different stars?
That's Asta Nebula.
Yeah.
It's the nebula, you're right.
Okay, Ron. So a supernova, there are different kinds of supernovas, some of which involve white dwarfs and some of which are very massive stars with a core collapse supernova.
Okay.
Then there's the kilonova, which is 2 neutron stars colliding with each other.
Oh.
Okay.
Do they explode?
Yes. And then there's a kilonova, which one is that? No, I'm sorry. The kilonova is the 2 neutron stars colliding, and the hypernova is a really, really massive star with like a gamma ray burst.
Okay, so it'd be like the difference between conventional explosives, an atom bomb, and a hydrogen bomb, I guess, as far as size.
Loosely, yes.
Oh,
now
wow.
there's 2 things going on here, 2 categories we're talking about. These HR diagrams that plot the evolution and all the different stages of an individual star are assuming that the star started with that mass and it never acquired any other mass along the way. It just lived on the mass it started with. These other things that Chuck was just enumerating, those things are where all of a sudden it gets a windfall profit of some new mass coming in. And that changes the whole game. The star can't handle it. So you get these things where you have a white dwarf that is near a red giant, and it's close enough that the gravitational fields are slowly pulling hydrogen off of the red giant and landing it on the white dwarf. And then eventually enough of it gets built up on the surface of the white dwarf that it collapses in itself and produces a nova.
So that would be a supernova.
Yeah, supernova, right. Okay.
And do they call that accretion, where it accretes? Yeah, okay.
Yeah.
And then you can also get two white dwarfs that are orbiting each other that merge, and that will also cause a type 1 supernova.
Right.
Oh, really? Okay.
So you have to get extra mass somewhere from something to get into these really big explosions.
Unless you're a very massive star to start with, and that's where you just get the core collapse supernova.
Yeah. As soon as you see that star forming, you should turn your rocket ship out and step on the gas pedal.
Get out of Dodge.
Okay.
Okay. What are we looking at here, Mr. Prez?
This is what the ladies came up with in 1890s. Oh, be a fine girl, kiss me. These are the spectral classes, and they go with temperature, surface temperature. So these are 2,000 to 3,400 Kelvin. These are all Kelvin. Here is our sun. Where is that?
It's a G.
Oh,
yeah.
Yeah. But this one, it says 4,900 to 5,700. Oh, that's right. Yeah, because we're 5,000 degrees Kelvin. 5,800 actually. So we should be up there, but the numbers are slightly off. And they have characters, and when you look at them, the color that they worked with is what appears to be, because astronomy was all visual then, and it was to the human eye what the color looked like for the star, and that is represented here in these globs. Here we are with a yellow dwarf star, a weak one. But also you can tell from spectral lines what chemicals are in it. Now, there are no atoms in these stars. The core of the surface of the star acts like a black body emitter. It gives this continuous rainbow band. These lines are atoms that are just above the surface of the star. As soon as it gets away from the surface, electrons can find their parent body and they can orbit, they start orbiting the nucleus, and you get whole, highly ionized, but whole atoms. And that's what gives you these black lines, because the light from the star below gets absorbed trying to get out through the atmosphere of the star, and it gets absorbed, and you see the absorption lines.
Electrons are smart.
Well, there's a few black lines that are in common. All of them.
Jerry, as we burn, we can actually change classifications there. Become the G star. Can it go to a K star?
Yes.
Okay.
So those black lines don't represent elements. They represent.
They do represent elements.
Oh, but you said there were no atoms. If you don't have an atom, you don't have an element, do you?
Just above the surface, though.
The nucleus defines the element, Ron.
Oh, that's true. Okay.
And you can see some of the lines are wider. That's telling you there's for example, there could be a stronger magnetic field that widens out the lines.
Okay, you hear about protons being thrown out from the sun in the solar wind. Are they just single protons, or are they big globules of?
No, they're single protons.
They're just single protons, but they get together and become 8, and there you got oxygen. They get 6, and you're carbon.
Yeah, but that's fusion. That's not just bumping into each other gradually.
Okay, but
no, the proton can accumulate an electron and become a hydrogen atom, an ionized hydrogen atom or a neutral hydrogen atom, depending on the thermodynamics. But basically, the stuff that hits the moon causes everything to age and do its weird stuff are protons, proton bombardment.
And do they stay on the moon and find a nice electron? And
Like, good question. I assume they stay on the moon.
Some of them do, yeah.
Yeah.
And some of them hit oxygen and you end up with water. You actually can get water produced that way.
Mm-hmm.
Well, the big question I think I asked you guys once, and you did answer, was if the fusion's taking place in the middle of the star, then what is the plasma we're seeing on the surface? It's not burning.
That's all the pieces.
It's just the pieces?
Yeah, it's like ionized hydrogen and ionized iron and ionized sulfur. And
okay, they're not atoms, or they're just protons running around?
They're just nuclei.
They're nuclei, yeah.
And sending a lot of photons our way. Okay, got it.
There's too much energy
coming from the fusion.
Yeah. There's too much energy for electrons to stay with a single nucleus. So if it gets to the nucleus, it immediately reionizes.
Those electrons are smart.
Right. In the vein of saying goodbye to winter, we say goodbye to the winter triangle. This is setting in the west.
Well, this is the summer triangle.
Excuse me. This is the summer triangle rising in the east.
There you go. I knew that. Sure I did. Vega, Altair, and Deneb. Okay.
Yeah.
Aquila, you said something about birds. Aquila.
Yeah. Deneb, this is the swan, Cygnus. This is Aquila, the
eagle.
Right. Vega is in Lyra. That's just a musical instrument.
Then there's a duck cluster out there somewhere.
That's near the tail of Aquila.
Oh, it is. It's a whole star cluster.
Yeah. Speaking of triangles, I heard there's a spring triangle.
There's a triangle every quarter of the calendar, apparently.
That's with Arcturus and a couple of other stars. Yeah.
The winter triangle, summer triangle.
I think it was Arcturus, Sirius, and Regulus or something.
Regulus is probably in there. Yeah.
Oh.
I did get an A in geometry, and I can tell you, any three stars up there, guys, become a triangle. So
bingo.
Unless they're in a line.
Oh, that's true.
The human eye has a tendency, because of the way we process images visually, we have a tendency to reference things as patterns. We're always looking for patterns.
Right. Like Cassiopeia's W.
Yeah.
Right. Okay, so tell us about the ducks.
This is the wild duck cluster. And I could show there's a lot of photographs of this online, but they just show a bunch of stars and there's no pattern to it, because a lot of these things were named when astronomy was very visual. And this is a drawing made at an eyepiece by, oh God, I forgot her name. But anyway, it shows the patterns that her eye has picked out. A photograph of this would show much less patterning. It would show a lot of the background stars that our eye tends to reject. So this is as close as you can get to why the wild duck cluster was named the wild duck cluster, because it looks like a line of ducks flying south for the winter. Sort of. That doesn't show on photographs. It doesn't show perfectly here, but it kind of hints at it.
Jerry, can you zoom in on that one?
Not the whole circle is not the cluster. It's in the middle there, isn't it?
Yeah, this is the cluster.
Oh.
That's actually like a gopher or a frog waving his arms and sticking his tongue out at you.
See the two eyes.
Yeah.
Wow. Okay.
When I was young, we had lath and plaster walls in our house, and they were rough finished, meaning that they didn't make them perfectly smooth. You could see little trowel marks and stuff left over. And in order to get me to go to sleep when I was a child, my mother showed me how to pick out different patterns and faces and scenery in the ceiling and look at it. And it worked like a charm. I was quiet in there for hours, watching battles in my ceiling. But that's the eye's ability to pick out things, patterns.
Okay, now how many different types of clusters? There's global, there's star, there's...
No, there's open and closed.
Open and closed. Which one is this?
Well,
this is an open cluster.
there's open and globular, which
Yeah.
Jerry called closed.
Yeah.
But they all orbit around each other, right? The stars, all of them.
They're gravitationally bound.
Okay.
This is one wild.
This is
duck one.
This is
Go ahead.
loosely gravitationally bound.
Yeah.
Call that the Daffy cluster.
This wild duck cluster, Jerry, is one that at star parties that I have a whole hard time kind of giving a description to when we see it, because it depends on the eyepiece, the scene that night.
Yes.
And so I tend to try to tell people, well, back when they discovered this, it looked like a bunch of ducks leaving a blind, and it formed a V as it was going up, and that got me in a lot of trouble. So I just kind of generally just say this is just a lot of stars. You know?
All right.
So
Okay, my cluster.
Here is M27, the Dumbbell Nebula.
Ah.
I only called Chuck's nebula because Chuck points it out at some star parties. So, but anyway, up here is the trapezoid of Lyra, the constellation that contains Vega, the really bright star. I think that defines zero magnitude.
Yeah.
And then you take the bottom two stars down here, Shellac and Sulapha, and you draw
Sheliak and Sulafat.
Oh, it's an I on it. Okay.
It's a T at the end.
Boy, it doesn't show that. But anyway, I'll take your word for it. So, and anyway, this shows this little green thing here is the M57, the ring nebula, of which we spoke. It's a planetary nebula with a 14th magnitude white dwarf star in the center. Most of your scopes will not show the 14th magnitude. 6-inch scope can reach 13 magnitude under a very dark sky. But if you have a 16 or 18-inch scope, you can see the star. What's his name brings a 20-inch? Schuler.
Charles Schuler.
So anyway, you can follow this down the line. It doesn't go quite to M27, but it gives you the general area of M27.
Ah, I never knew that, Hop. I got to try that.
Or coming up off the point of Sagitta the arrow at the bottom there.
Yeah. There, then go directly up. This would be an easy one because when you're on this star, then you just go in declination up and you hit it.
Okay.
So,
Vulpecula. Boy, does that sound ominous.
The fox.
yeah.
So what that is?
This is a picture of M27. This is a brighter than you would see in your eye. If you squint till it almost disappears, that's what you'll see. Photographs always show much more detail than images in the.
You know what I do for M27 is I make a rectangle for the stars in Cygnus, but it doesn't work all the time. So all those little added little hops that you had, it's going to help me to find this. This is one that I can struggle with.
Okay. The thing that, go ahead, someone wanted to say something?
Nope.
Okay. So if this one, you can get what's called an O3 filter, doubly ionized oxygen, or triply ionized oxygen. And you can put that on your eyepiece or screw it into your eyepiece and then look at this, because this has a lot of oxygen in it. And it will make this, it'll increase the contrast and make this easier to see. The stars will all be suppressed, but the planetary nebula will appear much brighter. So if you're at one of the outreaches and you're showing a planetary nebula, try and use an O3 filter. It really makes a difference.
There's one I've been taking out now and then, Jerry. It's a UHC-E, and that's kind of an economy version of the UHC that made in Germany. And what I like about it is it'll bring out your nebulosity or whatever, and it'll keep some of the stars. This is one of the objects I want to test this summer.
Okay.
Well, gentlemen, we still got the first quarter moon, solar filaments and prominences and some asteroid stuff to cover in 10 minutes.
Yeah, well, 12 minutes.
Well, okay.
Okay. Today we are at, you remember the last Monday we had an eclipse. It was new moon. So here we are 1 week later. We're at the first quarter. It's a very nice phase of the moon. There's a lot of detail right down the terminator, but we won't go into that. So this shows the moon in Cancer, which is where it's moving through here this week.
Oh,
this is the beehive cluster in Cancer. The moon is shown here at first quarter, so that's where it is roughly tonight. I tried to make this all topical for tonight.
That's what we're going to be looking at Encina Royale, is mainly the moon and the Orion Nebula, depending on how many people show up with scopes.
And where is that again?
Encina Royale.
Okay.
It's
that's right.
It's kind of to the north of the Caireal shopping area. It's a senior community.
Yeah.
Oh.
Got a little golf course.
Yeah, I know where that is. Yeah.
Yeah.
Near the Glen Annie Golf Course.
Okay,
no.
What's
not
that?
near Glen Annie. They have their own little golf course.
Oh, okay. Prominences are prominent.
This shows the surface of the sun in light of hydrogen alpha. The sun is basically made out of hydrogen with a few impurities. And if there's anything happening on the sun, it's happening in hydrogen. So you can get scopes that show just hydrogen light, which was used here to take this, or you can get it in other lights like chromium or things, but there's much less of that on the sun, so it's a much dimmer image. Your money is best spent on a hydrogen alpha scope. And this shows a prominence, and then a picture of the Earth to scale is superimposed on that to show the size of the prominence. Now, these things are tricky. It looks like all this flame is leaping up out of the surface, and it sort of is, but it's hiding the real culprit. This is the eclipse that we just had last Monday, a week ago, and we'll get to prominences again. But this shows this characteristic triangular, or I call it a capital lambda prominence down here at about 5:30. There's a nice one off here on the side, and there's another one up here. And this is just about about to cover up the sun or just about to uncover the sun, because you can see the sun starting to peer around here, but nothing on this side. So you can see these prominences on an eclipse, or you can buy a hydrogen alpha scope and you can see these prominences every day. Now, this is a picture of a prominence that was studied in detail. And just like that real red one we saw a few minutes ago, you can see these loops about this. And these loops are in the solar atmosphere. This is the surface of the sun, the photosphere. This is material that is partially lifted out of the surface, but the thing that happens is this is a magnetic field line that they twist up inside the sun. And there was a detailed modeling done of that prominence from September of 2013, and measurements made of the magnetic field lines. And it's the magnetic field lines that come out of the sun. They all twist up like a rubber band that has been twisted too much, and things start popping out in different places to relieve the pressure. Magnetic field lines do not start and end on a point. You see these ones, you can see that they've drawn them so they start and end on the surface of the sun. But every one of these things has to be a complete and continuous loop. So there's more of it underneath, and they all get twisted up. And that's why some of them get elbowed out of the sun. And when they pop up, they lift up material from the surface because of the constraint of a charge particle flying in a magnetic field. So, but if you look really closely, you can see the magnetic field line going up, but you can see all the material it lifted up. It's all raining back down. So the material actually is falling down while the loop goes up. And this is the same thing as it goes around. That's the side of the sun.
Do these start in sunspots?
If they concentrate enough, if there's enough of them together, then right where it goes through the surface, that will be a sunspot.
Okay.
But
do they get thrown out like solar wind and then screw up our telecommunications on Earth?
These kind of things do that. They can result, if it was thrown up with enough violence, then the magnetic field lines will break and reconnect, which releases a lot of energy, and that tears up it gives a lot of acceleration to the particles that lift it up, and so they leave the sun. But mostly they just fall back in the sun. But if it's real energetic, they can throw out a CME, a coronal mass ejection.
But it doesn't look like we've ever seen in those eclipse photos you showed something this big sticking out. These loops are pretty good. I mean,
those are quite large.
Something like
this
that.
is with the curvature of the sun. This is quite large, and these are the same size as that one.
Oh, really?
Just not zoomed in enough. So these things are bigger than the planet Earth. They're big events.
The sun is 108 Earths across, Ron, so scale it that way.
Well, I know, but the pictures showed it looked like it's a good third of the sun's diameter out there. I don't think doesn't that look like it's
no
arc of the sun? Okay, if you say so.
Yeah, this is a very, very large one, but it's still on the same scale as this one down there.
Jerry, your timing on the first quarter moon is great. I just got a message from Sky Safari that at 12:13 was first quarter.
Okay.
Perfect timing.
Okay, learning more, gentlemen. Can't wait for the test.
Okay, the sickle.
Ooh. Okay.
Okay, the moon is now working its way through. It's halfway between Regulus and it's between the legs of the lion. So
not right now, but it must be in a couple of days.
Yeah, this is Thursday, I think it is. You can see the moon is slightly gibbous there.
Yeah,
it's not at first quarter. A week from now, at Monday of next week, it'll be full moon.
Okay, so are they close to the asteroids we're going to be talking about?
Yeah, that's what this is. The moon is the finder thing for it's within a degree of the asteroid Juno.
Former planet Juno.
It's 2.2 degrees south of the moon at this time. So the moon this is south down here.
Okay.
And the moon is half a degree. So the fingertip is 1 degree away. So do that again. That's another 2 degrees. So right about here on this line is right where Juno will be. But this line won't be here to guide you. You have to count.
It's too bad.
Huh.
Now, speaking of asteroids, this fellow in Germany, Uwe Mehling, who has a 400 millimeter Zeiss Cassegrain,
wow,
400 millimeters, has photographed Ceres as an image. And this, at the time, Ceres is 0.79 seconds of an arc. That is, it's 3/4 of 1 second of an arc. Now, my experience with taking astrophotos here in Goleta is that I'm damn lucky to get stars that are three arc seconds in size, and that's because of the atmospheric disturbance, or what they call it, seeing. He's up in the hills somewhere, and he claimed it was a super good night, and so he may actually have captured the disk of Ceres. That's quite an achievement in my view. He takes excellent clear pictures of the moon. Shows a lot of detail.
16-inch Zeiss?
Yes, 16-inch Zeiss Cassegrain telescope.
Good grief.
Yeah.
Well, we're looking into the asteroid belt, and that's one of the larger ones.
Yeah.
That's the biggest one.
That's the biggest. That's a dwarf planet.
About 600 miles across.
You know, it recently occurred to me that, unlike Saturn with its rings, it'd be nice to see the ring around between Jupiter and Mars, wouldn't it? But you can't because they're scattered so far apart.
The average distance between anything of significant size, say a kilometer, is about 1,000,000 miles.
Yeah,
Well,
there's
what
no
it shows.
appearance of a disc.
That's not what I see in Star Wars. They're dodging them, the rocks. Fascinating. Did you want the interpretation of the caption that Bruce Murdoch, who may be listening and watching us?
No, I didn't deem it that important, and so I kind of left it in German for a little culture.
Okay, well, he translated it and sent it to us, and if you want it, maybe it's posted.
Sure, you could read it.
You know who else has a cat? Hold it up again, Tom.
Oh, he's gone. That's Elvis. That guy's called Elvis.
Kidding.
Oh,
You know a cat named Elvis? Wow. I know some people with a cat named Elvis. Quick recap of when are you coming back? What did you see? Or are you going to post some pictures, Tom, from the Midwest?
Probably some point if I ever get around to it. I need one of those round to it.
You saved the day for us today, I guess. A little late.
That was my solar eclipse photos I sent you guys before.
That was a nice image.
Yeah.
Well, I escaped from that.
Is it tonight you're going to be at another spot to watch the stars, Chuck?
Yeah, tonight we have an outreach for Encina Royale, which is a senior community in Goleta.
And then Friday we're going to be out at Westmont.
Friday at Westmont, and we also have Vieja Valley School on Thursday. But it's not going to be dark, unfortunately. It's a science that never gets dark.
And Totten, we had a nice innovative indoor experience at a little place called, what was it, Maria Hall, which they call the Courtyard Gallery at the Museum.
Yeah. I don't know if we're going to get a copy of that recording. Maybe John Winkowski might have it. He's not at work probably because he'll probably do it tomorrow or next day.
He's not until Tuesday. Yeah.
Hopefully he'll send me that link because I didn't see it on our Zoom account. I thought he was using our Zoom account, but Andre, you and I were both logged in to see anything going. You might have used the museum account again.
Well, what happened that people couldn't get in on the Zoom link is that Andy sent it out with Outlook, and Outlook munged the link. It happened that the dot between something like zoom.usa, the dot fell right on an arbitrary line length that Outlook puts on.
Okay.
And when it copied it and cut it, it left out the dot in the link, but not in the text that showed for the link. Yeah. So when you looked at it, everything looked okay. But when you actually hovered over that link and you saw the actual text, Outlook had thrown away the dot. And so people were getting all kinds of weird virus warnings and things when they tried to log on.
Yeah, that's right.
Nobody could see us, but it is archived somehow.
Hopefully you got it recorded.
Hopefully. Yeah. Well, Tom, we can't wait for you to get back. Tim, take care of your lovely wife there, Karen. And Chuck, say hi to Pat and thank her for getting me reimbursed on the checks I write for these guys. And Mr. President, sorry for today's problems. The Zoom gods have struck, but we got Tom Totten.
We sorted it out.
Exactly. We'll welcome you back in a week or two, Tom. In the meantime, trying to get through the construction, and we'll see everybody next week for number 165. Bruce.
Thank you.
Thanks, Jerry.
Everybody, bye.
Okay.
Take care.
Bye.